Hola, hola.
Claudio, ¿cómo estás?
¿Qué tal? ¿Cómo va? Ah, ya.
¿Ya
Es
se estás
una...
conectando gente?
Sí, claro, pensé que era primero una conexión entre nosotros. Veo ahí a Alicia Pérez
Sí, yo
Castol,
también pensé que íbamos a estar nosotros, ¿no?
que no la conozco.
Me
Hello,
voy,
hi.
me voy, ¿quieren que entre en un
No,
ratito?
no, para nada.
Y alcanzo a hacerme el mate de última.
Bueno, eso es otra
Anda a hacer
cosa.
el mate, anda a hacer el mate.
Me voy a hacer el mate y cierro todo y saco todo y en un ratito vuelvo.
Okay, everyone. Hey, how is
Hey,
everyone?
hi, Dr.
Hi.
Liebermann. How are you going?
Good. How are you?
Fine, fine. So many
Fine.
years.
Yeah, so many years.
Well,
When I see you, good memories.
yeah. You have good memory. Okay.
Lorena and
Yes. Well, here is Lorena, Alicia, and Valentina.
Hi.
Valentina. Hey, how are
Yes.
you?
How are you? Fine.
Are you
Yes.
following the Copa Cup?
Yes, of
Yes,
course.
of course.
You are originally from Germany, so for you is football, no, not soccer.
Yeah, I know. I can
Yeah.
use both. So I know. Yeah, it's
Yes.
soccer, but
Yeah.
football is fine.
And which team are you following? Argentina, I suppose.
Oh yeah, if you say so.
No.
Yeah.
No,
US.
tell me
US,
the
right?
truth. The
US.
US, okay.
And when we
Okay.
have Germany, right? We have the European Championship.
The European
The,
Cup.
the, the European Cup, yes.
Yeah. Yeah, and
They-
next week we have Olympics. So this like all day is like something going on sport. Except
Sports.
the webinar.
And you are a sport fan.
Yeah, I do. I watch sport. I do sport. I did marathon and
Yes.
soccer. I do swimming, riding, horseback riding if I can, and mountaineering. Yeah.
Yes. Thank you, Juergen, for being here today. As I told you by email, of course, it's a pleasure and an honor for us to have you as our guest today. Valentina Torres and me are going to moderate this session.
Okay.
And we are going to wait for some minutes because this is going to begin at 6 p.m.
Yeah.
I let me explain what are we going to do. First, I am going to welcome you in English. Then I ask for your permission to continue in Spanish, where I will thank those who made this possible. And Valentina is going to introduce you to the audience, also in Spanish, because it have no sense to say this in English.
Right.
You know your CV.
Yeah, I know. And
Okay.
but my talk is in English, right? So my slides
Yeah,
are.
yes, of course, yes.
Yes, and if there is any question during the presentation
English,
that is in
please.
Spanish, we will translate the question.
We are going
Okay.
to translate
Yep.
if we can.
Yes.
If we can,
And
yes.
Claudio, the honor is mine to be here with you.
Okay, thank you very much. Yeah.
I have about 75 slides, a lot of
Yes.
pictures, so we should be in that time frame you gave me.
Okay, that is one is an hour.
Yeah, easy.
Yes. And Valentina, we have an hour as a maximum, or we have some time. If Paula is here,
okay.
We have some more minutes for the questions.
Yes, you can extend a little bit.
Okay.
Okay.
Thank you. Your English is very, very, very good. So you are going to help us, Paula.
Mine? No, forget it. I learned watching television, so it's off.
Like
it's off.
my
you need
daughters.
a little bit more light. You are in the dark.
No, I need a new computer.
Oh, okay.
Too old.
Here we go.
Hola, Pancho.
I don't know. I didn't finish yesterday's game, Chile, Argentina. I just watched the first half. How did it end?
We won.
One
We
nothing.
won.
One.
Sí.
Who scored?
1-0.
1-0.
Who
Yes.
scored?
I don't know.
Okay.
No, no.
I guess Messi.
No, not Messi.
No, Messi, no.
Not
Not
Messi.
Di Maria. It was
I don't know.
Acuna. Jürgen
You are
knows more than-
searching. You are
Lautaro
searching.
Please.
Martínez.
Searching.
Ahí va.
Who-
Lautaro.
who-
Lautaro
Lautaro.
Martínez.
Okay.
Ah, sí.
Un cañonazo.
So sharing my screen is at the moment disabled.
Okay.
You make it able.
Yes, I'm going.
Okay.
That's
Yep.
right. You want to try?
Yes, I have to try. I have to find. Let's see. Let's share. What do we have here? That's that.
We see your screen.
Yes. Okay. But now I made it small. Now I have to make it large. Oh, here we go. No. Here.
We see your emails.
Yeah. Now I have to close this. Yeah.
When you click on share screen, you have to click again in the first screen in the pantalla. No sé, screen es pantalla, ¿o no?
Yes.
In the first.
The word screen.
Here.
Now try your presentation.
Yeah, but now my window is so small.
Okay.
I don't know. I don't. Why is it so small?
You have many items there.
Yeah. Let's see if I. This is weird.
Yeah. I've never seen it.
Share. See, now I have to open up my PowerPoint.
Yes.
Let's see.
Yeah.
Yes.
Okay.
Perfect.
We don't do much Zoom. You know, we have Team 365.
Okay.
So it should be fine. We should be okay.
Okay.
You have a do you have a video? Maybe you can try.
No video. No.
Okay.
No video.
Okay.
Okay.
We are go.
Do we use to begin on time, Paula?
No, maybe we can wait some minutes.
We can wait for 5 minutes. Okay.
Yeah.
Yep.
Okay. We are 24.
I just saw today 42 GVs. We had like only 5 cases, but we had like ridiculous numbers. One case had 74x and she had 16 GVs. So I had 42 GVs. I vitrified in 2 minutes. I warmed in 2 minutes and 40 survived. Tomorrow I will check the conversion. So you will see the numbers, you know, and it's also published. Now I need more people doing ICSI and FERT. But again, I have numbers from other people. They showed it works very well. Can you imagine 27 minutes down to 4? 16 freezing, 11 thawing, now 2 and 2. And I loaded 8 and 9x on one cryotop. Not 2.
Only one cryotop. Yeah.
No, I
8.
used 5. So 42x, I had 3 with 8 and 2 with 9.
Whoa.
Yeah,
That's a lot.
it's a lot,
Yes.
Yeah.
but still they survive.
And the volume of the
Your volume is, when you bring them together, it is not more than 0.5 microliter, right?
okay.
And I make
Okay.
one drop, and I don't suck up. I don't suck up.
Just one drop.
One drop.
Okay.
I don't do.
Okay.
Some people do egg. No.
No. That's okay.
One drop, and I have some slides. I measured like 1 microliter.
Yes.
Compared to like 6 GVs, you see the difference. The volume is small, and they obviously sufficient vitrify because they survive low temperature.
Okay.
And it's a benefit when you have a little bit volume, because you can easily take them away. I'm sure everyone thawed or froze eggs and thawed eggs in 1 molar sucrose, right?
Yeah.
Yes.
You know what happens, right?
Yes.
They go up.
They go up.
They get a ghost.
Yes.
It's extreme volume stress on the oocytes. If you use 0.5 instead of 1, you plunge your carrier, your drop is sitting there and is begging you to get picked up. There is no floating, there is nothing. There is barely a ghost.
You showed this about the volume in your talk during the International IVF Initiative. Yes.
Oh, okay. Thank you for joining that.
Yeah.
I saw.
I was only at the beginning. I couldn't listen for all the talk. But
is anyone going to Brazil end of August?
No.
No.
I know you don't like each other in soccer, but
we are friends of them in embryology issues.
I see that.
We are enemies only in football.
In football, it's terrible. It's always a bad game. It's like so much fouls and yellow cards.
Yes.
There's no soccer. There is just hitting and kicking and.
Do you see Brazil Costa Rica?
Yeah, so disappointing. Disappointing for Brazil.
Yes.
Yeah.
Okay, one more minute and
okay.
We can start.
40 participants.
Yeah.
So I have to move my slide. Okay, I'm just checking my slides so when I move.
Yeah, okay.
Okay.
Okay, now I have to go back. Okay, good. Okay.
Okay, we can start.
Start? Okay.
Yeah.
Bueno, comenzamos. Well, it is my pleasure and our honor to welcome Dr. Juergen Liebermann. We thank you, Dr. Liebermann, for being here with us today, sharing our webinar. We are transmitting together with Valentina Torres. I am very influenced with the America Cup. Sorry. Valentina and me are going to coordinate this webinar. This is SAEC, this is the Argentine Society of Clinical Embryology. And today's topic is minimizing exposure time and osmotic stress at vitrification and warming in human oocytes and embryos. As we already agreed with Dr. Liebermann, first, We are going to do the acknowledgements, and then we are going to introduce Dr. Liebermann to our audience, all of this in Spanish. Así que primero déjenme agradecer, I would like to thank Paula, Cecilia del Pícolo, Paula Jovaniec, Cecilia del Pícolo, Valentina Torres y especialmente Nair Suet, que hicieron de la Comisión de Educación, que hicieron todo esto posible. Y también a la Comisión de Divulgación de SAEC. Así que, Valentina, adelante.
Bueno, buenas tardes a todos. Les voy a presentar un poco del currículum de Dr. Liebermann. Él trabaja en el campo de la fertilidad desde 1995. Es director de servicios del laboratorio de Chicago Fertility Center en Illinois. Está asociado a la red US Fertility, Ovation, RMA New York Network. En 1995 se doctoró en la Universidad Técnica de Múnich y en 2004 realizó la tesis postdoctoral en medicina reproductiva experimental, también en Alemania. Tiene más de 180 presentaciones, es autor de más de 68 publicaciones, capítulos de libros y resúmenes sobre reproducción. Es coautor del libro titulado Vitrification in Human Assisted Reproduction. Es miembro de ASRM, R y ABNB. También es revisor ad honorem de Fertility and Sterility, Human Reproduction, Reproductive Biomedicine Online y, bueno, tiene el diploma como miembro honorario internacional CECOLFES de Bogotá en 2013 y 2017. Está casado, es padre orgulloso de 5 hijos, maratonista, triatlonista, montanista y buceador y, bueno, fanático del soccer, como nos dijo antes.
Gracias, Valentina. So, Dr. Liebermann, thank you very much again. Our webinar is yours.
Thank you very much to all of you having me. I have good memories with meetings with you guys in Mendoza and Mar del Plata. I don't know, maybe 10 years ago. It was always great to be there, and I've always had as a feeling of a very warm welcome. So I want to talk today about human oocytes and embryos, and how we can change protocols to make them more efficient without compromising their survival, their developmental potential, and of course, you know, their potential to implant and to achieve pregnancies. And my talk is split in 2 different sections. One is talking about clinical human blastocysts. We have had now for 2 years in a clinical setting. And then we have also human oocytes. I want to talk about, this is still research, but there is a lot of people, they already took over and did ICSI and did fertilization and PGD, all that stuff. As you might follow me on LinkedIn, if not, no worries. But, you know, I always post my stuff there before it gets previewed and published, so that people have a chance to see it earlier and to try it out. I just simply want to share it, because publication procedures are very long, and I will show you the timeline, how long it takes, you know, to get it published. But finally, you know, it's good to have peer review paper, but a lot of people feel more safe in doing this. You know, my first slide is a kind of disappointment, because if you feel we have to freeze less, you will be wrong. We will freeze more, because if you follow the numbers, you know, we have an increase, we consider an increase, a 10-fold increase in IVF cycles in the United States. And if it's the United States, it will be not different to South America. And we have, at the moment, 1 out of 6 couples are infertile. And when you see also with the cycle number, fresh cycles, the number of cycles of 4 cycles, if it's eggs or embryos, the freezing cycles of embryos or oocytes, it's all increasing. And I have also data here from Escher from last year in Copenhagen, and they saw like 30% now of all embryos worldwide are from frozen oocytes or embryos. And so I do it now for 96. I'm doing IVF, and I always had like 20%, but now in a sudden we see an exponential increase in freezing oocytes and embryos now 30%, and my guess, this number will go up to 40, maybe 50%. A big impact for us here in the United States is obviously PGD. We have a lot of patients, and now 80-90% are doing genetic testing, and so that requires freezing of the embryos. But so we will freeze until the end of my days and your days. There will be not less. And so the question is, the protocols we use so for many years, they're definitely solid, right? We just fought today 22 eggs I froze back in 2019, and 21 survived. So this is all good, but it was time consuming. It is time consuming freezing them. It's time consuming thawing them. And if we have a way to cut this down, to be more efficient, to have a more efficient workflow in the laboratory, that would be definitely something that gives us an advantage. So I will first talk about blastocysts. And so far we know that when we work with frozen material, oocytes, embryos, when we warm them, we require a certain number of steps to rehydrate them, so that we remove the cryoprotectant in a gentle way in different sucrose concentrations to prevent that water is rushing in, because that's the desire of water. It's rushing in. It follows like a simple osmolarity that it will balance this. And if we cannot control that, water would rush in and the cell would immediately die. And for that purpose, we use sucrose. So it's usually very common. It's a fundamental principle, to do certain sucrose steps. And if you still froze like slow many years ago, it was the same concept. It was even 3 or 4 steps to thaw the oocytes or embryos. And the idea is, to gradually eliminate the cryoprotectant and to rehydrate the embryo and to make that very gentle and to minimize the damage during this warming. And the entire process of, I mentioned that, is it eggs, embryos, it's time consuming and it's very labor intensive for every IVF laboratory. So if we would get like 100 or 90% survival with just one single step during warming, that would be a challenge, obviously, for the central dogma of cryobiology. And, with many things, you always need a little bit help of other people. And, I'm not forgetting here that we had people, they published that earlier. It happens actually in the United States by an accident. And you see some people published some abstract in 2021, a good friend of me, Teal Tyler, and in 2022. And when, after that, it was very quiet. But when I saw these publications, I went home and I started a trial in-house with in-house embryos donated for research. And so when you start like looking into something, you make like a list of things you think are they worth to challenge. Do we do the right stuff? For example, is the time of the procedure, is it right? Do we expose the right time? Do we use the right solutions, concentrations? Is it really necessary to load in more sucrose concentrations? If we use 1 molar, is maybe 0.5, 0.25, or even no sucrose possible. And then for many countries like Europe, they have problems to have media available with 20%. And they cannot add protein to their media. If they would do so, they get considered a vendor. So they only can work with 10%. So I tried also 10% as a media post-warming. And then finally, as I mentioned before, is actually a rehydration possible without sucrose? Is it visible? And so, as I mentioned, we did a trial. We thought all these embryos, blastocysts, they were donated for research, 564 blastocysts. And when we thought them, we split them in biopsied embryos and non-biopsied embryos. And we thought them all in one single step. And you see the survival is consistently high, over 90-95%. And even the survival, we kept them for 24 hours. Because, after warming, they look fine and you think they are okay and you call that survival. But this is not sufficient. You have to keep them in culture to see, how is their potential to develop. And so we kept them for 24 hours. And when we looked at their hatching rate, and you see out of these 564, close to 80% hatched completely. And when you look at the biopsied versus non-biopsied, that was an interesting finding for us. You see that close to 88% of the biopsied embryos hatching out by themselves. And none of these embryos were hatched after warming, right? We didn't do anything. We just thawed them and kept them in culture. But you see, for the biopsied embryos, the opening we have to do for the biopsy is sufficient that they get out of the zona pellucida. Whereas when we look at non-biopsied embryos, only 60% were able to come out. That means we would lose about 25, 27% of embryos if we would not do assisting hatching. And what we learned from this, that we keep assisting hatching for embryos that were not biopsied. And based on this, these numbers, I presented to our physicians, and they said, Juergen, if you feel comfortable, let's do this. And so we changed our protocol in September. And you see, I did research from May until September. And then in September 22nd, 2022, we changed our protocol. And this is our dish, how we freeze the blastocysts. We now using a total of 5 minutes. We keep them for 4 minutes in ES. And after 4 minutes, they go for 1 minute in VS, and then they get loaded on a carrier. For blastocysts, we use exclusively HSV, high security vitrification kit. It's a closed system where you load the embryo, you have to seal it, and then you plunge it. And now our warming is now 1 minute. We do a drop of 400 microliter TS. Obviously, it has to be 37 degrees. So we always have TS overnight in our incubator. And then when we take it out, you make sure, you have a heating stage where you have 37. We plunge the embryo for 1 minute, and then we put it in the transfer dish, and we keep it until transfer. Quite simple. We use as transfer media, sage blastocyst media. This is a remnants of the sequential media from the early days, where we used different media from day 1 to day 3, and then from day 4 to day 5. And we kept the blastocyst medium by adding 20%. This is our post-warming culture medium until transfer. And to just give you a perspective, right, when we talk about molarity of sucrose, we don't really know how much is it. 1 molar sounds a lot. It sounds more than 0.25 molar, obviously. But you can here compare, if we talk about 0.25 molar in a glass of Coca-Cola, you have 0.2 molar sucrose. And it's a lot of sugar. And so our embryos get exposed to a high concentration of sugar. And you can imagine how much now 1 molar is. Mm-hmm. And, looking at embryos, because people told me, Juergen, when you do this fast warming, it's a lot of stress on the embryos, and you will maybe pre-select your embryos. Poor embryos will die over the good embryos. And I have to tell you, I don't know how poor embryos will behave in this protocol, but we just simply don't freeze poor embryos, right? But you see that 75% or 80% of all embryos we thawed had a good score after warming and before the transfer, and only like 20% didn't look so great, but they still were able to do 70% positive beta, right? This is a slide just updated today, because today is 26, but our beta now 10 days back, so until June 15. We did 2,847 transfers, and we got 2,042 positive beta. That brings us to above 70% for all age groups, except for patients over 40. We're running around 65%. That's positive beta out of 2,847 transfers. And my table below shows you our live births. We have now 51%, 52% live births with an ongoing pregnancy of 50% and an implantation of 60%. The average weight and average pregnancy duration is not different to any other protocol we did before. So you see 3,200 grams babies, and pregnancy duration was in average 38 weeks. I want to show you also a little bit more in detail when we for with embryos. First of all, you see on top the age, patients classified per age. And I just recorded the most important thing for you guys: ongoing pregnancy and implantation. Implantation is consistently over 60%, except for patients over 40. It's 53% in average for all ages, 61%. When I looked at day 5, day 6, day 7, you see, of course, advantage in having day 5 embryos, where implantation is 65% versus about 58, 57% for day 6, and 47 for day 7. You see that day 7 is a small number, but we freeze still day 7. We have live births from day 7. And if I feel, and we have good embryos on day 6, but too early to freeze, we culture them another day. And you will have definitely additional embryos where you have a chance to get your patients pregnant with day 7. And when we looked at the untested and tested embryos, and you see, obviously, we would expect there is advantage for transferring euploid embryo. It's not much or not more as you might expect. It's 64% versus untested 57. But you see the impact of genetic testing if you go in my lower lines where I classify genetic testing by age. You see that younger patients have a benefit, not as much, but 6%. If we go to the older patients over 40 or 38 to 40, we see 55 versus 65, so 10%. And if we go to patients over 40, if they have no genetic tested embryos, where implantation is about 40%, 43% versus 57% if we have genetically normal embryos available for transfer. When, as I mentioned, for our European colleagues, because we have not availability of 20% media, I looked also in media with less percent, with 10%. That's usually our concentration. We culture embryos, 10%. And I looked also in using lower concentration. And, I can tell you that 0.5 as well as 0.25 molar works as well as the 10% post-warming culture medium works as well too. But obviously, we don't change too many times. At the moment, we use 1 molar, but just for you guys, lower concentration of sucrose works as well. So to summarize until here for the blastocyst, this protocol, it makes laboratory technique for warming blastocysts very simple, right? It reduces the unnecessary time blastocysts are exposed to room temperature. Before we had like 11 minutes, now it's 1 minute. And it reduces the stress to the blastocysts, there is no question. There is less time for radical oxygen species creation, and they usually have not a good impact on embryo development. So if we don't have them, we can also prevent an impact on the embryo development. Lower sucrose, 0.5 molar or even 0.25 molar, and lower protein concentration. It doesn't have to be 20%, works as well. And, we still figure out what's the right term. Some people call it ultra fast and so, but, I stick more because we don't really change warming or freezing. We change the duration of the rehydration and dehydration. So I prefer to call it a short dehydration, short rehydration. It's easy to implement in your daily routine and standardize your blastocyst cryopreservation procedure, and its outcome even more successful. So one-step warming protocol is superior to the multi-step protocol in terms of pregnancy outcome, supporting an optimized workflow by reducing labor to 95% as well, cost-effective, and my estimate was about 40%. So just to give you an example, we have usually 10 to 15 FETs a day. I needed 2 people to thaw them. Now it's done by 1 person, and the second person we now don't need for the thaw. We can put on something else, and so it's much more efficient. We take stress away from the people. Our job we do is already stressful enough, with all the attention to detail. So it will also your staff will love it if you implement it, and they will tell you, don't take it away when you have implemented it. So, now I didn't publish this, but it's a warming step without sucrose visible. And I just want to show you some data. And so I did here 122 blastocysts where I took them out of the nitrogen and I plunged them in 20% sage blastocyst media. As I mentioned before, it's our transfer media for the blastocysts. And you see, I kept them in culture. You see, there is a 97% survival by not using sucrose at all, and the hatching rate is far beyond 80%. So just for you, don't try it yet. I did one case so far, and it's one case I did because I was curious. She is pregnant and ongoing, and the baby, everything is so far healthy. So this is in the future something we should look into it. Just imagine how simple finally would be the warming of embryos out of the nitrogen right into your transfer dish. You see here's a blastocyst, right? I had biopsied and non-biopsied. That's right after warming. And then you see how they expand, right? And how they look after 24 hours thawed in the transfer medium without sucrose. So to summarize here, as I showed you the questions, and every scientist should have some questions if you want to look into something. The time of the procedure, we reduce the time of vitrifying blastocysts from 9 to 5 minutes, and the warming from 11 to 1 minute. Do we use the right solutions? In regards to blastocysts, yes, we use the right solutions in terms of VS and ES and also TS. If so, does it always have to be 1 molar? I showed you, you can go lower and blastocysts will survive. After warming, do we need to culture in 20%? No, there is no need. 10% works as well. And you see here, just a simple schema. 8 minutes before for vitrifying, now we are at 5. It's about 40% time saving. And when we warm them, you see we come from 11 minutes down to 1. That's over 90% of time saving per fall. Now we're coming to our interesting cells, the oocytes. I'm sure a lot of you also froze oocytes in the past and warm oocytes, and you also have a lot of patients that do fertility preservation and so on. So that will be my next part of the talk, oocytes. And the question is a real place for oocyte preservation, and you would agree with me, there is definitely a place for oocyte vitrification. This is an essential part of many IVF laboratories today. And you see, even we do it all. We see some posts on LinkedIn. You see how many people are still curious and interested in what I put on LinkedIn. So there is a huge demand. Even we think we can do it, there is still a desire to maybe improve and do something else as we do for now. And when we talk about oocyte vitrification, there is a couple of reasons, right? For example, no sperm availability on day of egg retrieval. If we have poor responder, it makes sense to stimulate them in multiple cycles to just accumulate their number of oocytes. Egg donation, it's much more convenient. It gives the intended parents more independency, flexibility, and it's time saving, you don't have to synchronize donor and recipient. Of course, fertility prevention in cancer patients, we have cancer patients, so we save their eggs before they start their therapy. And of course, age-related fertility loss, social freezing, or whatever you like to call it, and in case of premature ovarian failure. So this is all good reasons to be able to vitrify oocytes. Of course, the oocyte is a little different than the blastocyst, not just in cell numbers. Blastocysts usually on day 5 have around 120 cells plus 40 cells ICM. but oocyte is one cell. So there's a different ratio between volume and surface, and it makes them supposed to be harder. That's what we always thought about, right? Their permeability is different, the size, obviously it's a lot of water we have to remove without destroying anything. There is disaggregation of microtubules and myoric spindle depolymerization. There is a lot of other things like risk of epigenetic dysregulation, osmotic shock. So, when you look at this, it's actually hard to believe we can vitrify oocytes and farm them successfully. And, based on many years of research and finally data, Escher and ASRM released their research label from egg freezing in 2012 and 13. Until then, at least for my part, I had to write every year an IRB because it was considered as research. We were able to offer it, but it has to be an IRB, and we had to report every year, the survival and outcome. But that was done, and you see here, this is just our development in terms of egg freezing. I'm quite sure, I can replace it with graphs you made from your data. You see here that after this research label was removed, we have a steady increase per year in oocyte vitrification cases. So this is also something besides PGD and embryo freezing that takes a lot of work in every IVF laboratory. Every day we have like 2 or 3 freezes and thaws that takes always a lot of time. So we can say, as I mentioned today, for example, we thought 22x 21 survive in a standard vitrification protocol that takes a total 27 minutes, 16 freezing, 11 thaw. We can say that it's safe, it's repeatable, it's successful, and reliable. However, I think we're missing a puzzle. And again, like similarly to the blastocyst, I looked into this by making some questions, right? For example, time of procedure, is it the right one? Do we need to warm in 1 molar sucrose? Because this is like we all do, right? Do we need to stick to 2 oocytes? And if we load more oocytes, and I mentioned that before we started that seminar, do we increase the volume to an extent that we might have problems to get a vitrified state in the oocytes? A next point, I looked into it. Do we have maybe a protocol? Finally, we can freeze everything from GV to glyphid state embryos. That was always a part of my discussion. I never thought about, we can have a universal protocol. And then how important is it, can we use media? They are from different vendors. Are they compatible, right? I'm sure, you have patients that travel in Argentina from clinic to clinic. Embryos were frozen in a different media, like Claudio, you get, and what you want to do. You're not going in to buy this media where we're frozen, so you use what you have at home. So it's a good question. Does that work? Is it interchangeable, right? And again, do we need to?
Exactly.
I'm sorry.
No, it's like you say.
And then
it's exactly what you say.
Yeah, and then in 20% or 10%, usually also a dogma. We have to post-warm oocytes in 20%. The reason is that, of course, we need protein. It stabilizes the cytoskeleton until ICSI. We usually give them like 3 hours so that they recover from the warming. And then, most of us has eggs that were traditionally vitrified. It's a long protocol. Can we also thaw them in a shorter way, as I will show you? And then a question that was coming up many years ago, and there's only one publication, can we also freeze oocytes on a closed system? And the question for someone who is not familiar with closed and open system is simple, but a closed system doesn't provide a direct contact with the nitrogen because you seal it before. And so you might have a lower cooling rate compared to a direct contact, right? But is this cooling rate sufficient to vitrify them and that they survive? So a bunch of questions, more questions as for the blastocyst. And this is like an example I did by myself. This is how it looks when you vitrify oocytes. Like if you do 10 minutes or 15 minutes in ES and 1 minute in VS, you see that your oocyte will lose a volume. It goes from 100 to like 40%. And then, you know, if you give enough time, the oocytes recover, goes to 60% and then to 80%. And you see, you know, you actually don't have to be 15 minutes because the recovery is 80% already reached after 10 minutes. But if we plunge them again in 1 molar, in VS, I'm sorry, for 1 minute, you see another reduction in volume down to 40%. So a huge stress on the oocytes we might can prevent. So, and as I mentioned before, for the blastocyst, I had Tyler, and here I had a publication from Spain, maybe also Portugal, Gallardo, and he's a good friend, by the way, and we do something together. And he published something in a journal I never heard before, and when I found this publication, it had a couple of conclusions. It says, oocyte osmotic behavior indicates that the dehydration upon exposure to a cryoprotectant solution occurs within 60 seconds. Just think about it. In 60 seconds, the oocyte is sufficient dehydrated, right? And now we do 15 minutes at room temperature. That means that prolonging the exposure to the cryoprotectant does not improve the cytosolic class forming tendency and could be avoided, right? And then after 2 minutes of exposure to the standard cryoprotectant, the critical intracellular solute concentration necessary for successful vitrification was attained, right? So this was the important publication I picked up. It was like published in 2019, and you know, nobody really looked into it, right? And when I called him up and he said, you know, Juergen, I try to move on and to work on this, but my clinic didn't give me the chance and so on. I said, oh, I'm very sorry, but you know, this is great work, but you know, I will move on with this. And so we did a couple of things together, and we also will write a review together. So Miguel Gallardo. And then now if you look at protocol, what I will show you in the next pictures, you know, I put my cells in VS, when I put them in ES for 1 minute, right? As we learned in 60 seconds. And you see a volume reducing to about 57%. And then when we go to VS, there is another reduction. But, you know, we're not going back to 80%, right? Because the oocyte will not have time in that 1 minute to recover the volume. And there is no need for recovering. And then we just reduce again, just for a small percentage in VS, obviously, again, the volume, but not as extreme in the traditional protocol, right? So I feel we put much less osmotic stress on the oocyte, because these volume reductions is maybe something you like to see because you know water is taken out, but I'm not sure how much oocytes can take this. And you know, when I did my calculations on all that stuff, percentage, I just want to show you, you know, it's a simple formula, what you usually do to consider volume for a circle or for a round shape. And so this is how I was coming up with my numbers. And you see here, you know, based on this, what I just showed, when I graph that in a line, you see the traditional protocol, as you all know, right? We see a volume reduction, and then after time, the oocyte comes back, is recovering, is expanding. And then if it's like really expanding to 80%, we plunge it again to reduce it again to down to 40% of its volume. And when you look at the fast protocol, or, you know, whatever, I don't have really a term, maybe also short dehydration, you see here that is much more gentle, right? So volume changes, and so also the osmotic stress is not as severe as in the graph on top. And you see on the end, when you see here, after exposure to VS for 1 minute, reduces the volume again to a final volume of 40% after 16 minutes, right? 15 plus 1. And when you go in my lower graph, you see after 2 minutes, you get to 42%. So you get the same outcome in terms of dehydration of the oocyte after 2 minutes versus 60. And so finally, I started also my research with the blastocyst at the same time. you see a little bit a recording of my research on my office store. I need actually 5, 6 office stores, but I have only one. So, but it's always nice for myself to track down, you know, the development, because in the 6 months, and you see in November of 2022, and I started in May, I finally had the protocol where I now still work with, where I published, and what I will show you. So, and how is my protocol working? I have 1 drop of VS, usually 100 microliter, just for rinsing the oocytes, right? Everything is at room temperature. I never vitrify at 37. I did that too, but I don't like it, and for a couple of reasons. But here I do 1 drop of VS water solution. Then I have a 200 microliter drop of ES, and then I have 2 drops of VS each 100 microliter. And so I put them in the VS, rinse them, and then I put them on top of my yellow drop, that would be ES, and let them sink. And the oocytes will reach the bottom of the dish in about 30 seconds. But for sure, after 60 seconds, they are at the bottom of the drop. That means there is no exchange of water anymore. The cell is in equilibrium. That means osmolarity in and outside, extra and intercellular, is in an equilibrium, is isotonic, right? And if I have that, when they sink after 1 minute, I take them with VS, put them in VS in the first drop, rinse them quickly. They usually sit on the top. And then I take them from there with fresh medium from 4 and put them in the drop number 4 and wait for 1 minute. I don't move them around. I don't do anything. I just put them there and let the 1 minute work. And when I load them on CryoTop or CryoLog, I usually use the CryoLog, but you know, you can also use the CryoTop, whatever carrier you use at home. And now the warming, right? And the warming took me 6 or 5 months because, you know, we were also clued up with the TS, right? We thought we need this TS, as I showed you for blastocysts. We think we need the TS, right? On the end, we don't need any sucrose. But so for the X, it took me a while to say, man, should I go lower, right? And we know when we go lower, they will die because water is rushing in. Because sucrose is very important, right? There's a couple of very important functions during warming. But so I started with TS, and I said, voila, it looks great, it works great. So what I do is I have a 500 microliter DS, so 0.5 molar, and I put my eggs from the carrier right in this drop. You can pick them up, put them aside, and I wait 1 minute. There is no ghost, there is no rising, they sit where they are. And then I put them in the first drop of VS. But when I do this, I always bring enough DS with me in the first drop of VS. Because, you know, I don't want to make it too extreme, the shock, from no sucrose to, from sucrose to no sucrose. So I carry a little bit over, like a sandwich, and then the sucrose will be diluted in the first drop of VS. And after 30 seconds, you know, because I tell you I have only 1 minute in WS, after 30 seconds, I take them in the final drop of VS, that would be drop number 3, with no sucrose at all. So thawing in 2 minutes, 1 minute in DS, and 1 minute split in 30 seconds each, in with 2 drops of WS. And then I show you here, and I added with 42 GVs today. I started to try Irvine and Vitrolife, right? And I know I have no connections. I mean, I know these people, but you know, I don't use a medium because they tell me. But I tried these 2 media, and you see, first of all, good news is there is no difference, and that's GVs, right? And then I did the same for metaphase 1, and then you see there is also no difference in survival. Important is that the survival is consistent for these stages, over 90%, right? So when I have GVs like today, you know, we have no use for them, and I will freeze them, and you know, in 2 minutes vitrified and 2 minutes warming, it doesn't take me time, right? And when I keep them until tomorrow, I will take a look tomorrow how many of them converted, because I want to see, are we able to take their meiotic progression up and develop further. That means does the GV disappear, and you know, possibly also that the M1 is converting to an M2. And so this is my numbers on vitrified GVs. I thought in this protocol I showed you, when I kept them in culture for 24 hours or 48 hours. And when on the next table, you see G1 and GV2, one is vitrified, this is one, you see down the legion, and GV2 are the non-vitrified. Like, when we have on a daily retrieval GVs, we don't use them. I keep them for the next day and just see how is their development in our culture system or in an incubator, if they convert, what is their conversion compared to the vitrified one. And you see when we look at the conversion from GVs to metaphase 1, you see the vitrified over 90% converting to metaphase 1, and the same is true for the non-vitrified. And when we look to the metaphase 2, and you can see metaphase 2 from GVs after 24 hours, but sometimes you have to wait a little bit longer. Usually in vitro maturation systems, it takes 48 hours. You see their conversion rate now to metaphase 2, it's about 57, 58%. So there is no 100%, there is no 80%, but over 50% of these GVs converting to metaphase 1 and finally metaphase 2. And on the right side, you see the same for metaphase 1 oocytes, frozen, metaphase 1, and metaphase 1, 2 are fresh. And you see their conversion rate to metaphase 2, it's pretty much the same. It's about 85%. This is an abstract I want to show you, made by a group from Valencia, obviously Kirasado, and they presented this at Alpha this year in Lisbon, and they compared the standard protocol with the protocol with the fast protocol, and it is so we have to correct this. The protocol 1 is 10 minutes in ES and is 1 minute in VS, right?
Yes.
And when they warmed 1 minute in TS, they did TS, 1 minute in TS, because they didn't believe TS works. I was there, I talked to them, and I wouldn't say they trusted me, but they were very suspicious. And then they did 1 minute in VS. And the protocol B is exactly what I'm doing. It's ES and VS, 1 minute each. And then they started with DS and WS. But when you see the yellow one is over 90% survival, but even for the fast protocol, it's 97. But it was not significant based on their mathematic study they did. But if you look at the survival 3 hours later, there is a huge disadvantage for the fast warming. Over 95% are still survived, whereas you see the numbers going down in the oocytes we vitrified the traditional way. So let me correct this later. Again, the protocol A is 10 minutes ES, 1 minute VS.
Okay.
Right?
Yes.
So you see also here a simple study advantage was ultra rapid, and obviously also by using DS first and then WS and skipping TS entirely. Then I will show you just pictures here. This is metaphase 1 vitrified oocytes 2 hours later. Again, as I mentioned, 2 minutes vitrified, 2 minutes warmed. I used Vitrolife medium. When you see the GVs, you don't believe we were vitrified, right? The GVs are so nicely present. Believe me, we were vitrified in the same protocol in a total of 4 minutes. And you see here some GVs, and as I told you, in my table, I tracked them to metaphase 1, metaphase 2, and you see here, the same oocytes, 5 of them show clearly and nicely polar bodies after 24 hours. Here's a number of a group. I used Irvine GVs again. You see the GVs. I froze here 21 and 20 survived. You see the one dash on the right side. And we also converted here to metaphase 1 and metaphase 2. Of course, some of them staying at the GV, but the maturity again is moving on and coming out of the meiotic arrest and is progressing. But I didn't stop with the immature oocytes. I used also oocytes we can definitely call metaphase 2 There were not fertilized oocytes. There were always oocytes were converted next day. We didn't use for ICSI. And I did the same approach. You see there is no difference using Irvine or Vitrolife in my 2-minute freezing, 2-minute warming, where survival is over 90%. And I tell you, I was not very selective. I froze eggs you would never freeze, and they still survive. I did that also for abnormal fertilized oocytes, 1 and 3 PNs. And when you vitrify zygotes, they are very easy to vitrify, and their survival is almost 100%. And the same for cleavage edge embryos. I use cleavage edge embryos derived from abnormal fertilized, and their survival is also consistent. So I showed you data on GV, metaphase 1, metaphase 2, zygotes, and cleavage stage. And here we go. We have our universal protocol that works for all these different stages of human cells. You see here unfertilized metaphase 2 oocytes vitrified and warmed 20 hours later, Irvine. You see how nicely the polar bodies here, right? That's usually the first thing in our long protocol. They might degenerate. Nice and solid. And another cells here with Vitrolife medium, 11 metaphase 2. And I'm not showing you just pictures, where I have 100% survival, right? And then here again, a very important slide. I tried all these different combinations. I vitrified with sage. I warmed, I split the oocytes. I vitrified in sage, and I thawed in sage in Vitrolife. I did the same with Kitasardo. I did vitrification in Vitrolife, thawing in Irvine. I did Vitrolife and thawing Kitasardo, and this all works. So there's maybe some people they don't like this, but it is very important for all of us as embryologists. When you get in that situation, you get embryos from somewhere else, vitrified with something you don't have. You don't have to be concerned. You can use that protocol, or you can use your solutions, and it will work as well. And we do that for the blastocysts too, right? We get always blastocysts from somewhere else, and we use 1 minute for warming, and it works. And another thing I mentioned before, I was getting tired. Before we got told by higher authorities we have to vitrify 1 or 2 oocytes to make sure they survive. I always froze at least 4. Now here, you see here 4 metaphase 2 oocytes, and obviously 4 didn't survive, so 36 survived. That's 90%. And you see those eggs, you would not vitrify, right? But I vitrified, for example, 5 cryologs with 6 and 2 cryologs with 5, just to get to this 40. And you see, I had used my iPhone. It took me like 12 minutes to vitrify with 40 oocytes, and it took me 10 minutes to warm them. Now compare that to your protocol. I'm sure everyone, including us, would be nervous when we have to thaw 40 eggs, because it will take forever, right? So, and again, when we talk about the number of oocytes, you see on the left where I precisely put it 1 microliter with a pipette on a cryolog, a nice drop, a nice shape. And you see on the right a volume that contains 6 GVs. And this is my estimation, definitely 0.5 or even less microliter. So not comparable, even close to 1 microliter. And you see here again, and this is how I load, right? I don't suck up media. I don't stretch them. I don't flatten them. I think this is terrible, especially for people warming them. When they glue to the stick, you have to scratch them off and they die. Keep them in that volume. They will not fall off. They sit there and you pick them up. Very convenient, no stress. And we don't need stress. We have enough stress every day already. And so until now, I will stop showing my data and I will show you other data. They support my protocol. For example, there is recently a published paper. They call it ultra-fast vitrification mouse embryos. And they compared a control group to conventional vitrification. You see 10 minutes and 1 minute, and then ultra-fast 1 minute versus 1 minute. And you see there is no difference in survival. There's even a higher survival in ultra-fast. And they compared that to their control group of 200 non-vitrified mouse oocytes. And then they did a couple of other things. This is the same slide, so let's move on. And here they looked at the cytoplasmic reticulum, and they concluded, if it's a distribution of the cytoplasmic reticulum is entirely or peri-spindle, like the two slides on the left, they call it normal. If you have small areas of damaged ER, like on the right oocyte, they call it abnormal. And then they looked in the presence of clusters containing inositol. And I just write it down because not everyone knows inositol, but inositol plays a structural role in your body as a major component of cell membranes. And if you have clusters, they consider that normal. If you have no clusters or absence, they call it abnormal. And you see the slides down in graphs. First slide is that the vitrified, fast vitrified oocytes doing better than the traditional vitrified. They also do better when you look at the presence of clusters. They are even close to the fresh oocytes. You see 40% for fresh and 38% for the ultra fast, but you see the drop in the traditional vitrified of 10 plus 1 minute to 27. But analysis, when you look at the fluorescence intensity, when they analyzed this, there was no difference between these different stages. They also looked in the distribution here of mitochondria and the fluorescence intensity of this mitochondrial membrane potential. And I wrote it also down. The mitochondrial membrane potential is a result from a redox transformation associated with the activity of the Krebs cycle and serves as an immediate form of energy storage. So if you have this kind of stuff, then your cells obviously healthy, functional, and just doing fine. And again, they considered that even distributed as normal, if you get aggregation like in the two right slides, if you get this aggregation, they call it abnormal. And then they looked also in the fluorescence green and red. If you have two distinct colors, they call it at least green normal, and when it's a mixed color, they would call it abnormal. And when you look down at the graph, the first slide mitochondrial distribution, you see how the traditional vitrified oocytes drop down to 7%, right? Only 7% are considered normal, whereas the maturity is aggregation, what they call abnormal. But the ultra-fast vitrified is not doing like fresh, but definitely better than the traditional freezing. And when we look at the fluorescence, green and red color or mixed up merged fluorescence, you see here that the ultra-fast vitrified oocytes comparable in the percentage of the fresh one, whereas you have lower percentage in the traditional vitrified group. And finally, if you look at the intensity of the mitochondrial distribution, there is no difference between these groups. 174 between fresh and ultra fast, but again a lower number of mitochondrial distribution in the traditional vitrified oocytes. This guy didn't stop looking. They also did here confocal microscopic image of the spindle, and just as a summary here, the good thing is that at least with our even traditional protocols, the meiotic spindle does not get affected. As the tubulin and all that stuff is the same in fresh and in the ultra fast. There's only a tiny little speck you see the yellow on top of the traditional vitrified, but overall, the spindle does not get affected. And we know what from early studies back in 2004 and 5 that the meiotic spindle does much better than, for example, to traditional slow freeze. But again, no difference here in the freezing as we do it now and the ultra fast. And finally, they looked in what I mentioned before in the change of morphology of the exposure to the cryoprotectant. And you see here that the ultra fast has a similar curve as I have. There is not such an extreme volume change and stress to the oocytes comparable to the lower curve were what we all know looks like when we vitrify the traditional conventional long vitrification protocol. And finally, we looked in embryonic development, in fertilization, in cleavage and blastocyst formation. And you see here that, again, ultrafast does better than the conventional vitrification. They do also better in terms of cleavage and also in terms of forming blastocysts from these fertilized oocytes, even very close to the non-vitrified oocytes. Whereas traditional conventional long protocol drops down to only 10. So again, to summarize here, distribution pattern of the mitochondria is in favor of the ultra-fast vitrification. The presence of clusters and no aggregation of inositol is in favor of the ultra-fast vitrification. If we look at the meiotic spindle in terms of alpha-tubulin and chromosomes, there is no difference. That's a good news for us. And the relative less volume extrusion of oocytes over time initiated by CES is in ultrafast in favor of the ultrafast, as I showed you before, compared to the conventional vitrification. And then fertilization, cleavage, and blastocyst formation rates of oocytes following ICSI is in favor of ultrafast. So conclusion here, when we look at the volume changes repeated at similar endoplasmatic reticulum pattern, the control group and the ultrafast look very similar, but we have a negative impact from the traditional long freezing on the endoplasmatic reticulum. During reducing volume changes, the concentration or the contraction process, which is necessary to eliminate the intercellular moisture or water, led to meiotic damage. However, ultrafast vitrification results in less damage to the mitochondrial distribution, owing a smaller volume excursion changes, as I showed you. The conventional vitrification method may cause potential damage to crucial cell organelles in mouse oocytes. As we have to be careful, it's mouse, due to cryoprotecting toxicity and osmotic stress. And finally, the 3D images showed between conventional vitrification and ultrafast retains over 98% of the normal morphology of the meiotic spindle and chromosomes. And we see some numbers from an egg bank. I used my protocol for donor oocytes, fertilization, cleavage, and blastocyst formation, and euploid rate. And you see there's a fertilization over 90%, a cleavage close to 90%, blastocyst formation to close over 57%. And when these blastocysts to close to 62% euploid. So obviously not a negative impact if we vitrify these oocytes in a total of 4 minutes, 2 + 2, compared to 27 minutes. On the right side, he did also metabolic data, and he will publish that, or will show it. He has 2 oral presentation at Escher. But all this stuff, he looked into it, was in favor for the fast freezing environment of oocytes. And when there is a final question, when I'm done, can we fast farm oocytes? They are slow frozen. And so what I figured out, there is only one way. We have to bring TS back. If we have oocytes where we vitrified for 16 minutes, DS does not work. And the reason is, that they are soaked off with the cryoprotectant because they simply have longer time. So I have to bring the TS back, 1 drop of 0.5 milliliter. Then after 1 minute, we go in DS for 1 minute, and then we go in 2 drops of DS 30 seconds. So the whole protocol would be 3 minutes, comparable what we do traditional of about 11 minutes. So we would still come down to 3 minutes versus 11. And you see here, I started vitrifying embalming oocytes where were vitrified in 16 minutes, and I had only 1 survival out of 9, and I stopped. And then I did 43 oocytes, and you see M2s and 6 M1s and 41 M2 survived this way. So long way vitrified and then thawed in 3 minutes. And I did ICSI on them, and the fertilization was 83%. And you see here my first 9 oocytes, you see there is only 1 alive. So I knew that doesn't help, I don't have to do more. And when you see so oocytes, yeah, here, so fertilized oocytes, you know, in 3 minutes, and they look just nice. And finally, you know, a closed system, open system briefly. I'm not sure if you have experience with closed system. We use HSV, as I mentioned before. There's only 2 out there, HSV and Rabbit Eye. HSV you get from Cryo Biosystem, and the Rabbit Eye from Vitrolife. And I used here the HSV combined with Irvine media. I did 28 oocytes, 27 survived. Closed system, no direct contact. So survival 96%. And I did the same. You see the oocytes here. I have to move a little bit faster. And when the Rabbit Eye, as you might know, the Rabbit Eye is like a cryo lock or top, but it has a hole, and that's where you load the embryos or oocytes. And the oocytes, you put them right over this hole, and they will stay there because of surface tension, right? And I did 29 oocytes using Vitrolife media, because they make the Rabbit Eye, and you see all of them survived. Again, closed system that is sealed and then plunged. And you see here some oocytes I used with the Rabbit Eye and vitrification of with Vitrolife media. And you see also, you know, some abnormal oocytes, right? You never would vitrify, but they all survive. So to summarize here, time of procedure, it's definitely different than blastocyst. We can reduce the vitrification of oocytes from 16 to 2 minutes and the warming from 11 to 2 minutes. So overall, 27 down to 4. Do we use the right solution? Yes, for the freezing, but for the warming, DS instead of TS. Can we load more than 2 oocytes? Yes, we can. I would encourage like 4. If you feel comfortable, you can do 6. It will not compromise your outcome in terms of survival. So volume with loading 4 to 6, it's still smaller than 0.5 microliter. Can we freeze all these stages I showed you with one protocol? As I showed you, yes. We have a universal protocol to vitrify from GVs until cleavage stage embryos. Can we exchange the media? Do they deliver comparable results? Yes, as I showed. And are the media interchangeable? Yes, the protocol I showed you allows that these media interchangeable. And I just mentioned that. I just tested on that protocol. I would assume it is also for other protocols, but for this protocol, it's definitely interchangeable. Culture media post-warming, yes, meiotic activity is resuming in culture media with 10 or 20%. And fast warming, yes, we can fast warm if they were long vitrified, but we have to add 1 molar TS at the beginning as first step. And finally here, I'm not sure if you see it, closed system, do they work? Yes, as I showed you, and we don't need 100, 300, 400x. Closed systems work as well. And I'm not the first one who showed that. I didn't publish and I will not publish, but there is a group from Belgium. They showed that like 5-6 years ago using an HSV by successful vitrifying oocytes. So again here, oocytes 15-16 minutes down to 2 minutes total, 88% time saving. And when we talk about warming, we cut down from 9 to again 2 minutes. That is pretty much the same, 78% of saving during warming per freezing eggs. And you see here just my timeline. I started, as I mentioned, in May 22. When in September, we implemented in our laboratory on a daily routine. When I got my success with oocytes using 0.5 molar in November, my first submission to RBM Online was in July 21st. So paper was accepted. You see how long it takes, because I had one reviewer who knew a lot and had to share it with me. And so I got it published in November 16. And at the same time, I submitted an oocyte paper to FNS. They rejected. Same day, I submitted to RBM Online, and it got accepted in March 21. And now we're talking 2024. And I started in May 2022. And you see the 2 publications. If you have no access to them, just give me an email. I can send it to Claudio. He can distribute, so I can attach both RBF online papers if you like. Just let me know.
Yes, of course.
Right. And thank you
Okay.
very much. This is my team. And I always like, I had a tough case with oocytes. She went somewhere else. And it's not a made up story. She was not successful. She had 25 oocytes. 15 were somewhere else, fought. Only 2 survived, were fertilized, didn't develop. She had 10 left. She was coming to us, and we fought with 10. 9 survived, 8 fertilized, and we biopsied 5 embryos. She has now 4 normals, 1 we transferred, and she delivered a healthy boy. And she wrote with our healthy boy, a baby bird was born last week. You turned our difficult situation into a blessing beyond measure, and we are forever grateful to you. Thank you for all you do for us and so many others. And I want to include everyone here on this webinar because you do the same, and you make a lot of parents to, or couples to parents, and help them to get children. And
Thanks.
as a philosophy for life, I want to just share one thing from John F. Kennedy: change is a law of life, and those who look only to the past or present are certain to miss the future.
Miss the future.
And I want to conclude with this, with a picture of Chicago, my email, and a big thank you for holding out with me.
No, thanks you, Juergen. Thank you very much. This is so many. It's a fundamental talk. So many things to think about. We are almost 60 participants, and we are still all here. So there is a big interest in listening to you. I can say that one could say that your presentation is, among other things, about dogmas. That is some pre-established concepts that are being left behind. For example, the dogma of the stepwise procedure, the high concentrations of sucrose. And I ask if there is some questions for the audience. There are some questions.
I have one question.
Yes, Valentina.
You did.
Hi. But when we started doing the standard protocol, the long protocol, volumes are also important, they say, in that moment, because of the difference in temperature that you can have when you load the creatop, and also the number of oocytes or embryo that you are vitrifying. So my question is, if you are vitrifying more than 4 or 6 oocytes, you use the same volumes you have in your fast protocol?
Yes, same protocol. And many years before, I never vitrified 2 because it was just not efficient. And we were never concerned about the volume, and our survival and outcome was always good. But now, one day, oocyte egg banks, we usually started to vitrify 2 per carrier, and they made like lots, like 6 to 7 per patient. And that's where, it was introduced to vitrify 2 oocytes, not more than 2, for the reason of making sure there is a low volume. And people were so extreme to make it even lower by sucking up. For all these additional steps, right, where you always put additional danger on your procedure. Because, sometimes it's easy to suck them up. Sometimes you suck up the eggs again and put them back and all that stuff, right? So I want to simplify things by loading and be done, right? It's the same with a sealer. It's like sealers out there, when you seal straws, where
Yes.
you after the sealing, you have to look under the microscope to make sure it's a straw is proper sealed. This is bullshit, right? We need a sealer who seals and done and blanch. And so, all these additional steps may be made up by some people. There's a lot of people, they contribute. I'm not sure how much they really know.
There is a question from Annabella Marconetto. she's asking that following your ultra fast protocol, she wants to know if it is necessary to collapse them previously to do an assisted collapsing. In case
Very
of
good.
yes,
Yes,
if
very good
yes,
point.
have
I
you
have to mention this.
evaluate if the results are worse without collapsing them?
So I have to mention this. So we started artificial collapsing in 2009, and since we do it, right? So it's less embryos we have to collapse because now we have like 90% of cases are biopsy. And so there's also, if I ask this auditorium, when you have to biopsy embryos, and Argentina can do biopsy, right?
Yes.
Yes.
It's allowed. So
Yes, of
those
course.
people, they think we have to make an opening on day 3. Those people, they think we need an opening on day 4. And when those people, they think we don't need an opening, or maybe on day 5. So I'm someone who doesn't do anything and just makes an opening right before the biopsy, right? And so we do, when we have embryos, they are not for genetic testing. They have a fresh transfer, or they are a freeze oil cycle, but no genetic testing. We do artificial collapsing. And we compared that many years ago, as I mentioned, 2009. There is a benefit for the embryos when you can release the water to a huge proportion. So, the cryoprotectant has to do less by pushing the water out. So we do assisting hatching for all embryos they are not biopsied. For the biopsied embryos, you don't have to do it because by collapse. We also we vitrify blastocyst collapse immediately, right? There is also people, they biopsy and put them back in the incubator and let them re-expand. I don't understand why. So, we have always teams, they biopsy, and when the team is waiting always to freeze, so they are like in post-biopsy in 5 minutes vitrified, right? Just it's not a part of a talk, but there's so many other things that comes in our field. I don't know by who, but you have to be cautious. And I learned that the hard way. One day I stopped listening, and what I heard, I try it out. And you see that on my blastocyst or X, where other people were just collecting data to make publication. I started sharing because it's good to have more people trying it, so we all have a benefit.
Okay.
Also,
I told you.
collection, yes.
Yes. No, I told you that this
system
is
collecting, very easy. Sorry, Claudio. We
no,
have laser,
sorry.
right? We use a laser because with biopsy we have free laser. We make one single shot, right, on a connection of 2 trough ectoderm cells. So there is not really an opening of the sonar, but that shot collapses the blastocyst. It takes depending on the day 5, day 6, day 5 collapse faster than day 6, but usually, we collapse them, put them in the incubator, makes the paperwork. 5-6 minutes later, they are ready, they are collapsed. It doesn't happen immediately.
In your paper, the blastocyst paper, you wrote that you do assisted hatching even in the blastocysts that were used for PCT, that they had already assisted hatching. So, and this is why, because you had the experience that they did not hatch at 100%, even with a previous assisted hatching. This is a very important point in your paper, I think.
Yes. So, one thing we talked about, assisted collapsing, right? This is pre-vitrification. And, we do assisted hatching, definitely more generous on non-biopsied embryos than on biopsied embryos, right? But it depends. Sometimes, you have embryos where were biopsied and they still sit in the sonar. Before them, usually all like in the morning. And again, 10, 15, 1 person. And then there is some embryos, because we do retrievals first, and then maybe fresh transfer. So some embryos, many of them like 2-3 hours post-warming in the dish, right? So we get a very nice assessment how they developed in these 3 hours, and when we can still make a decision, doing assisting hatching or not. I'm a little bit more conservative, if I feel, there is no need, when we don't do it. But, if I feel, the patient will have a benefit to help this embryo coming out, and we know that after freezing, the zona pellucida is changing, right? David Gardner showed that many years ago with the zona hardening, it makes sense to do something to help these embryos to get out.
Yes. I think you need to know that this talk is very important for us because in Argentina it's the same as the United States. There is a growing number of egg freezing.
Yeah.
And I think that this is the same in the rest of Latin America. For example, in our clinic, we perform 400 egg freezing per year.
Yeah.
This is almost 25% of our cases.
Yeah.
And this is growing every year.
Yeah.
So that's why I mentioned
mostly advanced age, or is it just single women at a younger age?
Yes, no younger age.
Yeah,
that
would be great too.
You have all the ages.
There is not much we can do if we vitrify oocytes.
Yes,
we know
yes, of course.
They are mostly abnormal.
But now you have more people from younger ages due to the advertisement. Yes.
Yeah. Very good.
That they told you not wait too late.
Yeah.
Do this now.
Yeah. And even so, if you maybe don't need them later, you at least have a kind of backup. You have a kind of insurance, right?
Yeah.
You never know when we find the right person.
Well, because some yes. Okay. Some other questions? Háganlas en el idioma que sea, castellano, chino. Do you understand some Spanish?
No. I'm sorry.
Okay. No.
Sorry. Did you say that you prefer warming and room temperature, or the process, and that's why?
Yes. So the warming, so vitrification, right? Vitrification, because there is like Vitrolife, their protocol says 37 degrees. And their protocol is also very fast because when you do 37 degrees vitrification, follow your, your cryoprotectant penetrates faster, right? You don't have to wait as long. But I also saw that at 37, your cryoprotectant solution gets easy, thicker and thicker, right? So I prefer room temperature, and for warming, always 37 degrees, always.
Okay.
Right?
Okay.
For oocytes, I know there's protocols out there. You go in TS at 37, and then you go to room temperature, and on the end, you move up. I don't do this. Just think about, why should I change the temperature? They like 37. Why I go back to room temperature? So my protocol, and also when I warm oocytes from a long protocol, I stay after TS at 37 degrees.
Okay.
In your paper, you use only 6 minutes in the first step of the stepwise vitrification procedure instead of 12 or 15 minutes.
For blastocyst.
This is because you have previously collapsed the blastocyst, so you need less time to dehydrate them. Yes, okay.
Right, but it was also, it was also to speed up the procedure. We had like 9 minutes before, but you're right, with assisting collapsing, you definitely also can cut down time because a huge proportion is already released by the cell, and it doesn't have to be done by the cryoprotectant. So we cut it down from 9 to a total of 5. So 4 minutes ES and 1 minute in VS. And, our outcome data, everything is as usual.
Okay.
And also you have seen that ongoing pregnancy and is better with the faster vitrification protocol. And also you have less abortions. Maybe this is what is happening in the blastocytes is similar what you saw in oocytes with mitochondria and also the rearrangement of the cell, or do you
Yeah.
think that is another thing that is happening?
No, I think it is pretty much, I'm sure it's very comparable. Unfortunately, I'm not sitting in these cells. I cannot observe it from right there. But, point is, we reduce the time at room temperature, right? That's usually not good. We don't culture embryos at room temperature. And then, we allow them faster to absorb water, but not too fast, right? Too fast, we know what will happen. Just dump one oocyte vitrified in media. It doesn't work with X. It works with blastocysts, but it doesn't work with X. So I think, using one step, we're reducing the time outside at an unphysiological temperature, but also allowing water to come back. You have to keep in mind when we go in, for example, TS, as long as you put them in TS, they don't re-expand. That's our purpose, right? We want to control the water influx. But if they don't re-expand and water doesn't get in fast enough, we can also have a different scenario because of the solutes inside. They are at a high concentration. They can have a toxic effect too. So we want to get these solutes back to where water, that they get dissolved, and then that the cell can regain cell activity in terms of meiotic, mitosis, whatever it is. So I think these short protocols, they all coming down to the same, if it's blastocysts or oocytes.
Sorry, I didn't see 3 more questions in the chat. The first one is from Fran Leocata. Hello. This the recovery time before the ICSI, if it is the same between the ultra fast vitrification and the conventional.
Yeah, I would do. Yeah, I would do the same. I mean, it's a moment, except you have time left. We have to follow certain time frames, not to miss the fertilization, right? If you have time left or you do genetic testing, and I think, Claudio, one day actually we will not do any more FERCheck, right? Because if we do genetic testing or you have time left, you have that chance to go back and to see what is normal and abnormal. And it would be a huge impact, because if we have like sometimes 20, 25 retrievals, we don't have to wait. We strip 30 minutes of the retrieval and we do ICSI an hour later, right? Mm-hmm. We don't have to stick in that time window. That sounds like utopic, especially for people like you and me. We are so long in that field, but I will predict, not long, we will not check any more fertilization.
Okay.
We have this discussion already with 1 and 3 PN to keep them in culture because they have a potential to be normal. So I stop right here.
The second question, sorry that I am in a hurry. When you do the big dishes at 37 centigrade, do you use oil to avoid evaporation? Is the word?
No, there's no over oil.
Without
no
oil.
Okay.
Of
oil. No.
Okay.
You have to be careful, right? TS anyway would not work with oil, right?
Okay.
You cannot plunge a carrier in the oil. Your embryos will be in the oil. You can overlay DS and WS, or I did that in the past, but no, there's no need. When we 4X, we always have also more than one dish, right? When we have our first shit TS, we have 20X, we always make like 2 or 3 more dishes of TS. So you have to make sure that with TS, don't use it too many times, because when you use it too many times, you take it out. Temperature will drop fast, right? Because of no oil. But it's still in an area where it will be fine. So I saw, like, for example, my drops, they drop like in 1-2 minutes from 37 to 35, right? But that's okay. That's okay. But now think about, you stay 16 minutes without oil. Your temperature drops even down to 30, right? And we know spindle will depolymerize, and I don't know what impact that will have.
Okay. Romina Rolando is asking if there is any modification that you observe in the oocytes with this novel protocol. She means about the membrane of the oocyte. You mentioned a lot of about mitochondria and inositol, but what about the membrane?
I know I didn't see any difference. I
Any
mean,
different?
what I always would recommend to wait for ICSI at least 2 hours. So when we vitrify, I'm sure you do the same. We usually vitrify them based on the trigger, like 2 hours after retrieval, right? So you want to vitrify eggs fast, right? You should not have them for 6 hours and vitrify, because they soon leave the body, they start alterating. So we vitrify them not later than in 2 hours. So 8 o'clock retrieval, stripping 9, and then they are vitrified at 10. And for warming, we usually do like warming at 10 o'clock in the morning. So when we give them 3 hours until ICSI, and all our ICSI is usually done between 1 and 2 o'clock, just to catch that time window at 6:30 in the morning when we start working.
There is another question from Annabella Marconetto that I do not understand. She says, sorry, this is with the conventional technique we used to overlap the protocols. Have you tried to do it with your protocol, your fast protocol, and make it also faster? If Annabella is here, she can.
Maybe she was thinking about,
yes.
long traditional vitrification and then warming fast. Maybe she was thinking about this. Maybe. I don't know how.
Okay. Yeah.
Right.
Yes.
But as I showed.
Yes, this is the question. Yes, of course.
Right.
Yeah.
So yes, as I mentioned, I looked into this, and you have to come back to TS. But again, these 3 steps takes 3 minutes versus 11 minutes. Again, it comes down to the shorter time outside of the incubator. I think this is always essential, and we all seasoned experienced embryologists, so we know the value and importance of 37 degrees Celsius.
Yes.
Have you ever used your fast protocol without collapsing the embryo?
No. For the blastocyst?
Yes.
No.
No.
As I mentioned, we traditional and we do artificial collapsing since 2009. If embryos are not biopsied.
I was in Atlanta also, and they also collapse embryos. In US is like tradition to collapse the embryo before, because you have laster since ever. Maybe here is not, we are not so used to that, but since we are now doing more PGT, it's we have that. I think that all that you have said today is we see it in the lab, the difference, how when we vitrified collapsed embryos that were biopsied before versus embryos that are not collapsed. You see that they really like expand faster and do that exchange faster.
Yeah. I'm not sure if there's a difference between, it's hard to compare the non-biopsied versus the biopsied. Even you do like no collapsing on the non-biopsied, because there will be definitely a benefit. There is no guarantee, 100% guarantee for pregnancy using a euploid embryo, right? There's only one thing: the embryo is genetically normal, but it still needs the same requirement to implant like a non-biopsied embryo, right? And it's only important for older patients where we know, because the number of eggs they start with is already at a high percentage abnormal. That's why we know we can increase their implantation and ongoing pregnancy and reducing the miscarriage. And that's what I showed, the ongoing pregnancy, the clinical pregnancy was not different, but the ongoing pregnancy, fetal heartbeat and SEC was in advantage of the fast warming. And when you have more ongoing pregnancies, you have a reduction in miscarriage. Both things go together.
Yes.
What about multiple pregnancy?
Again, sorry, Paula.
What about multiple pregnancy rates?
Multiple pregnancies. Oh yeah, no, this is. I love to talk about this. I mean, we started single embryo transfers, and I know you know that US was famous for multiples, right? Because we transferred a hell of embryos. But we started in 2007 doing elective single embryo transfers. We have about since then 4,000 single embryo transfers for blastocysts. One embryo, and you see that on the implantation, right? One embryo, if it's genetically tested, one embryo.
Yeah, okay. But I know there is a relationship between assisted hatching and there are many papers relating assisted hatching and multiple pregnancy.
Yeah, that's supposed to be what people say. So when I tell you out of our 4,000 single embryo transfer selected, that means there was another embryo we didn't transfer, right? Not just an ESET, selective. None of these day 5 fresh transfers were hatched. None of them. There is no need. And we have a monozygote twin rate of about 5%. So not using laser, we get some monozygote twins. People love to believe it comes from the laser. I don't think so.
Okay.
So certain patients, certain embryos, whatever happens in utero, and I think it happens in utero, the ICM splits off.
Okay.
I saw maybe 1 or 2 in my life before transfer, right?
Yeah. Okay. And what about assisted hatching on vitrified oocytes?
So when the oocytes get injected, they develop to blastocysts, and then we have to see how they look like. Many of them do genetic testing, so it would be neglected. We would do biopsy, but if the embryos coming from these oocytes, vitrified environment, we would definitely look into assisting hatching because they were vitrified environment already, and now will be again vitrified as a blastocyst, right? What we don't do is conventional IVF. I don't like conventional IVF with frozen environment oocytes.
No. Yeah, I agree. Thank you.
Paula, it's 7:30 here.
Yeah.
Almost all the participants are still here, but I think we are abusing Juergen time.
I don't know. It's my pleasure here to be here. No
okay. you are very kind with us. I don't know if there are any other questions from the audience. If not,
I know here.
Okay. Thank you very much.
Juergen.
Thank you.
Hi, Dr. Liebermann.
Hi, Nair. Thank you very much to you.
Hola, hola a todos.
Hola a todos.
Muchas gracias a todos por estar hoy aquí y también quiero agradecerle, por supuesto, al Dr. Liebermann por su tiempo. Thank you, Dr. Liebermann, for your time. It's a pleasure for us listen to you. Your presentation. Así que bueno, gracias Paula, gracias también al doctor Claudio, por supuesto, y a Valentina, porque muy amablemente se ofrecieron como oradores hoy, la verdad que nos ayudaron un montón, así que gracias.
No, thanks you for the idea and for doing the contact, y gracias a todos por haber participado, todos los participantes, muchísimas gracias. Thank you again, Juergen.
Thank you, doctor, for being so generous with the information. You have a lot and you share just like this.
Thanks for being with me. Have a great summer and you all be safe and well.
Okay.
You too.
Bye.
Si quieren los papers, me los piden. Fácil. cvicioli@pregna.com.ar y me los piden. Bueno. Bye.
Thank you.
Bye.
Gracias a todos.
Gracias a todos.